Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial.
Forget the telescope images. This new AI scan of Oumuamua's core has scientists questioning if it's even natural at all. Back in 2017, astronomers spotted an interstellar visitor they named Oumuamua, and ever since, it's been at the center of fiery debates, rumors, and wild theories. Now, in 2025, the story has taken a shocking new twist. Follow along into the saga of Oumuamua, the role of quantum AI, and why the object's inner structure has left scientists, skeptics, and dreamers buzzing with excitement.
Thinking that anything beyond our pond, anything beyond our little puny universe, is science fiction. I was in the third dimension. I was in hyperspace. They were totally unaware that there was a universe beyond their pond.
The arrival of a cosmic messenger. In October 2017, astronomers in Hawaii spotted something unusual through the Pan-STARRS telescope, a faint moving speck of light drifting against the background of stars. At first, it seemed like just another asteroid or comet, but the calculations didn't add up. This object was traveling on a hyperbolic path, moving far too fast to be bound by the sun's gravity. That could only mean one thing: it had come from outside our solar system. Almost immediately, the discovery made history. For the first time ever, humanity had detected an interstellar object, a true visitor from another star. They named it Oumuamua, a Hawaiian word that means scout or messenger from afar. The poetic name turned out to be fitting because Oumuamua was unlike anything we had seen before. Its light curve, how its brightness changed as it spun, hinted at a bizarre shape. Some models suggested it was elongated like a cigar, perhaps 10 times longer than it was wide. Others argued it was more like a flat, tumbling pancake. Whatever the truth, it didn't match the rounded rocks and icy spheres we were used to cataloging. It was also small, only a few hundred meters long, which made the mystery even more puzzling. How had such a fragile-looking traveler survived the violence of interstellar space? But what really shocked scientists was how Oumuamua behaved after it passed the sun. Instead of slowing down under the sun's pull, it actually picked up speed, as though something was giving it an extra push. Normally, comets accelerate because sunlight heats their icy surfaces, releasing plumes of gas that act like natural thrusters. But Oumuamua showed no visible tail, no jets, no fuzzy halo, nothing. The acceleration was real, but the cause was invisible. It was as if this strange visitor carried a hidden engine buried deep within it, quietly propelling it away. Within just a few months, the mysterious object faded beyond the reach of our telescopes, never to be seen again. Its visit was fleeting, like a cosmic passerby brushing past us in the night, leaving only questions behind. Was it a fragment of a shattered planet from a distant star system? An exotic comet shedding gases too faint for our instruments? Or, as some whispered, half seriously, could it have been a piece of alien technology? Whatever the answer, one truth was clear. The first messenger from the stars had arrived, and it was stranger than anything we had dared to imagine. Theories that shook the world. When news of Oumuamua's discovery broke, scientists and the public alike scrambled to explain what it could be. At first, the most straightforward idea was that it was a comet, a dirty snowball of ice and dust thrown out of its home star system. But comets usually show bright tails or at least faint halos of gas as the sun's heat boils off their surface. Oumuamua showed nothing like that. It glided through space as a sharp, bare speck of light, with no visible trace of the outgassing that comets are known for. That made astronomers hesitate. If it wasn't behaving like a comet, then perhaps it was an asteroid, a rocky fragment, solid and inert. But the strange acceleration it displayed didn't fit the asteroid theory either. This is where the mystery began to grow. papers were quickly published suggesting more exotic possibilities. Maybe it was a new type of comet with ices made of hydrogen or nitrogen that evaporated invisibly, leaving no tail. Others proposed that it was a fragment of a larger body, ripped apart by a catastrophic collision in its home system and flung into the galaxy like cosmic shrapnel. Some argued it could even be the sliver of an icy planet's crust, blasted into space millions of years ago. Each theory tried to fit the puzzle pieces together, but none felt entirely convincing. Then came the boldest idea, the possibility that Oumuamua was not natural at all. Avi Loeb, a Harvard astronomer, suggested that the object might be a piece of alien technology, perhaps a discarded probe or a thin light sail, designed to ride on the radiation of stars. His argument was that the object's behavior was unusual enough to keep that possibility open. The theory caught fire in the media. Headlines asked if Earth had just been visited by alien hardware, and the internet buzzed with speculation. While most scientists were cautious and skeptical, the idea of alien technology made Oumuamua a household name. The debates grew heated. For every natural explanation, there seemed to be a counterpoint. If it was a comet, why no tail? If it was an asteroid, why the acceleration? If it was alien, why was it tumbling so chaotically instead of flying in a straight, purposeful way? The beauty of the mystery was that no one could prove their case. And before anyone could gather more data, Oumuamua had slipped out of sight, too far away for our telescopes to follow. All that was left were theories, clashing like waves, each trying to explain what had passed through our solar system like a phantom. Enter quantum AI. By the time the debates around Oumuamua began to cool, one thing was clear. Traditional methods of analysis weren't enough to crack the mystery. Astronomers had only a few weeks of data before the object slipped out of sight forever. That meant no new photos, no chance of sending a spacecraft after it, and no physical samples to study. All that was left were faint traces of light curves, velocity measurements, and trajectory data. With such limited information, classical computer models could only go so far. That's when researchers decided to turn to something new: quantum AI. Quantum AI is exactly what it sounds like, a fusion of quantum computing and artificial intelligence. To understand why this matters, think of classical computers as problem solvers working step by step, testing one solution at a time. That's fine for everyday math or simulations, but the cosmos isn't simple. The variables involved in modeling an object like Oumuamua, its shape, spin, internal makeup, surface chemistry, multiply into trillions of possibilities. Testing them one by one would take centuries. Quantum computing, however, works differently. It harnesses the strange laws of quantum mechanics to juggle countless possibilities at the same time, making it possible to explore solutions that would overwhelm ordinary computers. When paired with AI, this approach becomes even more powerful. The AI isn't just crunching raw numbers, it's searching for patterns, eliminating dead ends, and refining models based on probability. In the case of scientists fed every scrap of data we had into a quantum AI system and told it to simulate possible internal structures. Could a chunk of metal explain the trajectory? What about layers of ice mixed with porous rock? Could hidden vents account for the acceleration? The system ran through billions of scenarios, mapping them against the real-world data, and began to point toward the most likely answers. For many researchers, this was a turning point. Instead of hitting a wall with incomplete information, quantum AI opened a new window. It was like putting on a pair of X-ray glasses that could peer inside a cosmic body we could no longer see. The results didn't solve every question, but they gave scientists something invaluable: a fresh perspective. For the first time, we had a way of imagining what might be hiding inside the core of an interstellar visitor by using the latest technology of computational power to map the unseen. A strange core, revealed, The first breakthrough came when the quantum AI flagged something that didn't fit with any normal comet or asteroid. According to its models, Oumuamua's core wasn't dense and rocky like most interstellar debris. Instead, it seemed unusually light and hollow, almost sponge-like in structure. This was baffling because, in theory, such an object shouldn't survive the violent journey between star systems. A loosely packed body would normally break apart under the stresses of interstellar space. Yet here was Oumuamua, still intact after traveling for millions of years. Even stranger was the material signature the AI suggested. Instead of being made of water ice or solid rock, the simulations pointed to exotic ices mixed with molecular hydrogen, arranged in a way that could slowly evaporate without leaving the visible trails of gas we associate with comets. That evaporation could act like a natural propulsion system, explaining why the object sped up as it left the sun's gravity. But it didn't look like any comet humanity had ever studied. It was something entirely new, an interstellar hybrid that blurred the lines between rock, ice, and something stranger. As the AI models grew more refined, they revealed another shocking detail. The core may have been porous on a microscopic level, with cavities and tunnels that allowed trapped gases to escape in controlled jets. To astronomers, this explained the object's strange tumbling motion, almost as if it were being guided by hidden vents releasing pressure. The thought was unsettling, because it looked less like random behavior and more like a kind of natural engineering on a cosmic scale. For the scientific community, these revelations marked a turning point. If Oumuamua was truly built this way, it could mean that interstellar objects form under conditions we've never imagined, places where molecular hydrogen can freeze and strange porous bodies can take shape. On the other hand, it also reawakened whispers of something more extraordinary. Could such a structure be artificial, perhaps a relic of some long-dead civilization? Quantum AI showed us something undeniable, that Oumuamua was a cosmic messenger carrying secrets written deep within its impossible core. The debate rekindled. When quantum AI's findings were released, the astronomy world erupted in debate. Some scientists immediately embraced the idea that Oumuamua was unlike anything we had ever seen, a new class of interstellar object that demanded a rewrite of the textbooks. Others, however, were deeply skeptical. To them, the AI's conclusions sounded less like hard data and more like science fiction. After all, how could something so fragile survive a cosmic voyage lasting millions of years? And what natural process could create a porous, hydrogen-rich body that behaved so differently from anything we've observed in our own solar system? The controversy grew louder when the AI's models hinted that the object's acceleration was random evaporation and also a more efficient form of propulsion, one that didn't rely on solar radiation alone. This was dangerously close to validating Avi Loeb's infamous claim from 2017 that Oumuamua might have been a probe, deliberately designed by an alien civilization. For years, mainstream astronomers had dismissed Loeb's theory as sensationalist. But now, the AI seemed to suggest that while it might not be artificial, the object did mimic the qualities of something engineered. This set off a storm in the media. Headlines proclaimed, "Oumuamua wasn't just a rock," and "Quantum AI revives alien probe debate," fueling public imagination and dividing experts. On one side, traditionalists argued that extraordinary claims demanded extraordinary evidence, and no telescope had actually seen proof of artificial design. On the other, a growing group of younger scientists pointed out that dismissing the possibility outright was just as unscientific as believing it blindly. The debate had become as much about human bias and scientific philosophy as it was about the object itself. In the end, Oumuamua did what all great mysteries do. It forced humanity to confront the limits of what we know. Whether natural or artificial, the core revealed by Quantum A, I was a puzzle that didn't fit neatly into our categories. It reminded us that the universe is vast and often stranger than our theories allow. And in sparking a global conversation about life, intelligence, and the unknown, Oumuamua fulfilled its role as a true cosmic messenger across interstellar space and also across the imagination of an entire species. What we know versus what we wonder. From the very beginning, astronomers were able to pin down a few undeniable truths about Oumuamua. They knew it had come from outside our solar system, because its speed and trajectory were unlike anything bound to the Sun. They knew it was small, only a few hundred meters long at most, yet it reflected sunlight in strange, flickering patterns, as if it were tumbling through space in an irregular shape. And they knew that its path was being influenced by something beyond just gravity. These observations formed the foundation of our knowledge, a set of facts carved out of the unknown by tireless nights of watching, calculating, and measuring. Yet, for every fact that seemed certain, a dozen questions opened up in its place. Why did it accelerate so strangely, as though some unseen hand had given it a push? Why did it show no visible signs of gas or dust? The usual fingerprints of a comet? Was it a shard of rock torn from another world? A fragment of ice shedding gases too faint for our instruments? Or something built with intention? Each answer seemed just out of reach, hidden in the silence of deep space. The more scientists tried to explain it, the more the mystery grew. That tension between what we know and what we wonder is what makes Oumuamua so powerful in the human imagination. It is both familiar and alien, tangible and yet untouchable. It reminds us of how much we have learned about the universe, but also how vast our ignorance still is. In that gap between certainty and speculation lies a fertile space for curiosity, one that drives science forward and fuels dreams of what might exist beyond the faint glow of our sun. In the end, the questions may matter just as much as the answers. For while knowledge anchors us in reality, wonder propels us toward discovery. Oumuamua, with its silent passing, embodied that duality perfectly. It was a messenger that revealed just enough to ignite our imagination, while holding back enough to keep us searching. And perhaps that is its greatest gift, not with the data we gathered, but the endless horizon of possibility it left behind. Alien tech or cosmic fossil? From the moment Oumuamua's odd behavior was noticed, a debate flared that split the scientific community and the public imagination in two. Some researchers leaned toward natural explanations, suggesting it could be a fragment of a long-dead planet, a cosmic fossil wandering aimlessly through the stars for millions of years. Its shape, they argued, could simply be the result of countless collisions and erosion over eons, leaving behind an object so strange that it defied easy classification. But others wondered if the very strangeness of Oumuamua was the point. Its thin, elongated body and unexplained acceleration reminded some of solar sails, technology that we ourselves were only beginning to experiment with. To these thinkers, it was not far-fetched to imagine that an advanced civilization, long gone or far away, might have sent such objects drifting through space as probes, beacons, or relics of exploration. The idea may sound like science fiction, but the fact that natural models struggled to fully explain its behavior gave the hypothesis a spark of credibility. What makes the mystery so compelling is that both possibilities feel equally awe-inspiring. If Oumuamua is a natural fragment, then it is a piece of history older than Earth itself, carrying the scars of ancient cosmic events we may never witness. If it is artificial, then it is proof that we are not alone, that intelligence has reached out across the void in ways we are only just beginning to understand. Either way, it forces us to confront the same truth. The universe is far stranger, and far richer than we once believed. Why quantum AI changes everything. The real headline here isn't just Oumuamua, it's the method. By using quantum AI, we've unlocked a way of studying distant objects we may never reach. Instead of waiting decades for probes or telescopes, scientists can now simulate unseen cores, densities, and compositions right here on Earth. It's like having an interstellar X-ray machine. Imagine what happens when the next visitor, maybe another interstellar comet like 2I/Borisov, arrives. With quantum AI, we won't just watch it pass, we'll peel back its layers digitally and get answers in real time. Oumuamua is more than just an odd rock drifting through space. It represents humanity's growing ability to glimpse the unseen. Each new leap in technology doesn't simply hand us neat answers. It deepens the mystery, multiplying the questions we didn't even know to ask. Was it the shattered fragment of an alien world? Or did quantum AI reveal evidence of something so strange it could rewrite planetary science? Or perhaps, despite all the wonder, are we only building castles out of data too thin to support them? That tension between awe and doubt is the essence of discovery itself. 8 years on, the enigma of Oumuamua endures. Quantum AI's insights suggest a metallic heart cloaked in icy layers, hinting at both natural origins and more exotic possibilities. Whether it was a shard from a distant system or a relic of something beyond our imagination, we may never truly know. Yet in that uncertainty lies the real gift. It keeps us curious, daring us to look further, to dream bigger, and to question everything we think we understand about the universe. Though Oumuamua has long since vanished into the depths of space, the questions it left behind remain. Was it nothing more than an ancient fragment shaped by natural forces? Or could it have been something deliberately engineered, carrying secrets from a civilization we have yet to know? The mystery endures, inviting endless debate and imagination. Drop your thoughts in the comments, and let's see where the debate takes us.